All right, let's describe some more rational functions. F of x is equal to x minus 2 over x squared plus x minus 6. Quadratic under a linear term. So first step, let's try and factor out this quadratic. What multiplies to negative 6 adds to 1? Well, 6, you have 3 and 2. How can we manipulate 3 and 2 to get 1? We can do 3 minus 2. So this, same thing as x minus 2 over x minus 2, x plus 3. And then now we have terms that actually can cancel out. So let's cancel that out. Cancel that out. And our function now becomes f of x is equal to x plus 3 over 1. Ooh, I almost just wrote it with the x plus 3. So, easy as pie, we know that we have a vertical asymptote at negative 3. 1, 2, 3, right there. And then this isn't being moved up or down any way. So we can also just say that our horizontal asymptote is also going to be at 0. Cool, even amount. So we can just write our function like so. Voila, and we are done. Pause. Something here is not quite right. If we left this function as b, x minus 2 over x minus 2 times x plus 3, technically, there should be an asymptote at 2. What happened? This is what we call a removable discontinuity. It's an integer that when we put it in the regular function, the unchanged function, we get an undefined answer. It's not an asymptote. If it was an asymptote, then this graph would be different. Now, the reason it's not an asymptote and it's just a point on our graph is because, let's say, see, 2 is our asymptote, okay? So if we put in 1, or 1, just in, 1 minus 2 over 1 minus 2 times 1 plus 3. These are going to cancel out anyway, so it's going to get us a 4. If we put in 1.99999999 minus 2, that very small number, over the same thing times x plus 3, 1.9999, these are going to cancel out, and we're still just going to get 1 over whatever that is. It's just at that one point that it is undefined. That's why we don't see this behavior where it just approaches and then never touches. It goes through, it passes through it, but it is not defined in our graph. So in order to find this hole, we plug in that undefined value from the original function into our new one. If our undefined integer is 2, we put in 2 here. 1 over 2 plus 3 is going to be 1 over 5. So at 2, 1, 2, our solution is going to be 1 over 5, period, but we're going to leave it empty. We're going to leave a hole there to show that it is undefined at that point. So, regarding all the things we use to describe, we have a vertical asymptote at x equals negative 3, and then we have a horizontal asymptote at y equals 0. X can't be equal to -3. We also have to include this whole, this removable discontinuity. So we can just say there is a removable discontinuity in RD at, and we denote this using the coordinate. There is a hole at this point on the graph, which is just 2. And then the output for what we put that in for our new function, which was 1/5. Pretty neat.